Hello students, welcome to this session on rational numbers which we are going to discuss from class 8 mathematics textbook. You might have studied the different number systems till now, that is the natural numbers, the collection of natural numbers the collection of whole numbers, integers and now rational numbers. But before we switch over to the content proper, let me discuss with you something about what our national curriculum framework and the textbooks intend to do and what we expect from you. How do you can use this textbook in the context of the content, and the national curriculum framework emphasizes the need for developing the ability to mathematize ideas. What do you mean by mathematize? Mathematize means you are able to think in terms of mathematics, that is in terms of logic. Logic is the base for mathematics. So, how well you are able to develop this logical connection and try to develop the concepts in mathematics, that is what we intend when we develop these textbooks, and that is what the National Curriculum Framework 2005 that was framed in the year 2005 for you all. Before reading the textbooks, at least you must have an idea what is expected of you and how you should try to assimilate the knowledge, try to apply the knowledge that you are gaining. It is not that knowledge will be given to you, you have to put yourself, whatever knowledge you have from the previous class, try to develop that knowledge with the help of the teacher. Teacher will throw you in some situation and you need to try to explore the situation and try to develop some new concepts. That is what is expected of you. And what will happen due to this? After the completion of school years and maybe in later years of your life, you will be having a very enriched life where you can see mathematics all around you. You will be able to do things in a logical sequence and so get the most economical and best fruits in your life. And so we want that there should be a mathematical base in your life and you should try to read mathematics from that point of view. Mathematics is not just a collection of some theorems or axioms or principles or algorithms that you are studying. How do you divide the numbers or how do you add the number? It is not just that, it is how these concepts are developed, what are the things that around you that compel you to come to these particular results, and that is what the National Curriculum Framework wants you to do. The main points in this National Curriculum Framework 2005, they suggest relating mathematics to development of wider abilities in the children, that is in you. So, we want that mathematics should be responsible, mathematics should be useful in the development of wider abilities, whether you are good in any sports or any other event, how mathematical thinking will help you in doing that, how mathematical thinking will help you in planning the events that will be more fruitful to you and in a very economical way how you are able to do things. So, that particular thinking we wish that it should be developed in you. So, do not look at the textbooks merely as giver of knowledge, but try to explore things for yourself. During our conversation, during our discussion in these video series, we will try to explore the things with you, and I expect that you at your end will try to do it with your family members and friends. Whenever you get a chance, try to discuss the things. The most important part of mathematics is the vocabulary of mathematics. Understanding a concept, understanding an idea, how it has been mathematized and expressing it in your own words is also an important thing. So, the important concern for us has also been to ensure that all students at this stage learn mathematics and try to feel confident. Never feel that you will not be able to do that, you will be able to do that. Try to speak about it with your friends, with your teachers whenever possible, and try to verbalize the things. Merely the expression 2 plus 3, what does it mean? Try to understand that, try to verbalize that particular thing. Is it the combination of 2 apples and 3 apples, or is it the combination of 2 things and 3 things taken together? These things you need to speak before you actually do 2 plus 3 is equal to 5. It is just a mechanical thing when you do this 2 plus 3 equal to 5. So, Class 8 mathematics textbook, this is in the series of the textbooks that have been developed right since class 1 mathematics, that is the primary mathematics, and at the upper primary stage class 6 and class 7. You have been studying about various concepts like unitary methods, ratio and proportion, percentages, etc. All concepts are interlinked. One concept relates to the other concepts, and one concept once it is learned, how we can develop and generate another concept, that is more important. For example, ratio and proportion is the basic thing. From ratio and proportion we use unitary methods, and from unitary methods we can switch over to percentage. Percentage is again a special case of ratio and proportion again, and from percentages we do lots of things in our daily life. For example, in the banking transaction or in any other transaction in your life, you should try to list the things. Where do you use percentage? Percentage of, say, water in the milk that the milkman is serving you, that is also a daily life example. So, there are the concept of percentage is useful in all walks of life, and this particular thing has got basis in ratio and proportion in unitary methods. So, this particular connection, if you try to understand, if you try to give value to this particular connection, then you will become more happy and you will feel that mathematics is not just jumbled set of algorithms and principles, but one by one, like a flow of water, how the concepts are coming out, that you will be able to experience, and this is what we want you to do. So, coming back to rational numbers now, you have studied rational numbers in class 7, where they have been introduced to you. So, before, as I said earlier, embarking on the rational numbers, I just wanted to discuss these things with you, so that you will be able to read the content in that particular spirit, and you will not feel that something hard is being thrust upon you. So, what are rational numbers and where do you find these rational numbers? For example, you have studied integer, you find numbers, natural numbers that you call or counting numbers, because you are able to count 1 light, 2 lights, 3 lights, 4 lights and hundreds of trees, hundreds of persons, 1156 persons sitting in a playground. So, these numbers, when I say, these I call as natural numbers, 1, 2, 3 or sometimes 1056 and so on. These numbers you have studied in lower classes, where we call them as natural numbers or counting numbers, and from there you proceeded to the numbers that we call integers, that is numbers of the type -1, -2, -3, then 0, 1, 2 and so on. So, that includes the positive integers as well as negative integers and 0 as well. And where do you get these contexts? For these numbers you can get many contexts, because you have the things that you can count, you have the number of laptops, you have the number of friends in the classroom. How about this? As soon as the context changes, when you find the things around you that need to be quantified, that needs to be assigned a quantity to make our life simple, we arrive at this particular concept. A person standing under a tree walks 1 meter to his right, and another person at the same place walks 1 meter to its left. Now, this 1 is the quantity, but the direction in which they are going are opposite. I have borrowed 1000 rupees from someone and I have given 1000 rupees to someone. The mode of transaction is different. At one place I have taken money, at other place I have given money, and the number is involved there, that is 1000. So, how to address this problem so that I am able to write it mathematically at one glance? If I say it is -1000, I should be able to say that I have taken money, and if I have given money, then I will say it is +1000. So, that minus sign and plus sign has got some significance, and that particular significance generates, that particular need for such situation generates the concept of integers. These we call as integers. Now, my question is it necessary that a person will walk only those number of steps, or though that particular distance which comes in whole, like -5 kilometers or +5 kilometers or +7 kilometers? Is it not possible that the person sitting under a tree or standing under a tree will walk, say, 2.5 kilometers towards the left and 3.5 kilometers to the right? Now, how to denote these particular numbers? The way we denoted integers, the way we generated the concept of integers, in a similar way these particular numbers can also be generated. We can assign the plus and minus sign here just to indicate that opposite things are happening. 3,500 were given to someone, 7,500 were taken from someone. So, 7.5, 3.5, they are not the numbers of the type the whole things, they include some fraction there, and that fractional part along with the number will take you to the number of the type say rational number that we call. So, rational number, so we are getting 2.5 kilometers to the right and 3.5 kilometers to the left. Instead of just 2 kilometers or 3 kilometers, where we would have indicated this as +2 and -3 or 3 and -2, whatever it is just indicating the oppositeness of the situation. Here I can say that it is say 2.5, whereas I can indicate that this is -3.5. I have generated the concept of numbers that are now new here. The integers were there because they were in that form of whole such numbers, but here we are getting fractions as well along with the numbers, and so we call such numbers. Now, there is another context here. Suppose I take the equation 2x minus 4 is equal to 0. You have studied equations in class 7 and as well as in class 6, and you know how to solve such equations. So, when I say 2x minus 4 is equal to 0, I can solve this and get x is equal to 2. What is 2? 2 is a whole number, but if I get an equation of this kind, it is not necessary that I will always get equation where I will get whole number answers. So, I can get such equation also where I say that 2x minus 3 is equal to 0. Then what will be the solution of this equation? I will get here x is equal to 3 by 2. You might say that this is a fraction. So, there is a difference between a fraction and a rational number, but that I will come later on. Now, here it looks like a fraction, but suppose I take an equation of the form 2x plus 3 is equal to 0. What will you get as the value of x here? I will get x is equal to minus 3 by 2. If you solve this equation, you will find that you get x equal to minus 3 by 2. What is this minus 3 by 2 again? This is not the same number, same kind of number rather that we were getting earlier. We are not getting numbers of the form 2, minus 3, 5, 3 by 2 like that. I am getting a number of this form. So, such numbers like 2 by 3, minus 2 by 5, minus 6 by 7 and so on, they will be rational numbers. But are these the only numbers? What do you observe about these numbers here? You will find that there is one number, it is sort of in a fractional form, where one number is in the numerator and the other number is in the denominator. This number is in the numerator, this number is in the denominator. What is this minus 2? Minus 2 is an integer. What is this 2? 2 is no doubt a whole number, but in general I can call it an integer as well. Similarly, what is this 5? 5 is an integer again, and so we find that we are getting these sort of fractions where the numerator and denominator both of them are integer, and so we formally say that we formally define a rational number or we call a number a rational number if it can be expressed, if it can be expressed in the form p by q. I have shown you the numbers where in the numerator as well as in the denominator you had numbers, we had integers. So, I am now formalizing in a formal way, I am trying to express the number as p by q. What are these p and q? P and q are integers, p and q are integers. Can we afford to have a number like this 2 by 0, or can we afford to have a number like this minus 3 by 0? No, because you are going to get an undefined number at the moment. I will call it undefined number at your stage. So, these numbers will not work. So, what is the condition we should put here? We say that q is not equal to 0, q is not equal to 0. So, p and q are integers, the number is of the form p by q, where p and q are integers and q is not equal to 0. So, such a type of number is a rational number. Now, according to this definition then, so look at the numbers that you have studied earlier. For example, say now the number 2. Can it fit in this particular format? Can I say that this is a rational number? Think about it. What is a rational number? Number of the form p by q. Can it be expressed in the form p by q where both of these are integers? I can write this as 2 by 1, where 2 is an integer, 1 is an integer. I can write this as minus 4 upon minus 2. Both of them are negative integers, and when I simplify this, I get this number as 2. Or I can write this as 6 by 3. There are many such ways of writing this particular number. Try to generate more such numbers, try to take up such numbers and try to find out that you get more and more such values for such numbers, and you will find that all these numbers are in the form p by q, where p and q both are integers, p and q both are integers, and q is not equal to 0. At none of the places you will find that q is 0, at none of the places you will find that q is 0. So, I can write the number 2 in this particular way. Basically 2 is a natural number, or you can say it is a whole number, or you can say it is an integer as well. So, every integer I can express in this particular format. How about 0? Can I write 0 in this form? Yes, 0 can be written as 0 divided by 1 or 0 divided by 2. Try to generate a chain of such numbers for yourself, and you will find for yourself that 0 can be written in all these forms. And so, I can say that now what is 0 here? It is an integer, this 1 is also an integer. 0 is an integer, 2 is also an integer. Again 0 can be written in the form p by q, where p and q both are integers. So, we can say that 0 is also a rational number. It means that, or if I take one more example here, if I take the example of minus 3, can I write minus 3 in this particular format? Yes, minus 3 can be written as minus 3 by 1 or minus 6 by 2 or 6 upon minus 2, both of these things are same, and so I can generate many more such fractional forms where I get the value as minus 3. So, it means that whether it is a positive integer 0 or a negative integer, all of them can be expressed in the form p by q. So, what is our conclusion then? We conclude that every integer is a rational number. Every integer is a rational number. Every integer is a rational number. Now, can you tell me whether every natural number will be a rational number? Yes, because every natural number is an integer. You take 1, it is an integer, positive integer. You take 2, it is a positive integer. Whole numbers, they are also integers, because 0 is an integer. Whole numbers start from 0, 0, 1, 2, 3, 4, 5, 6 and so on. So, all of them are integers, and therefore, they are rational numbers as well. So, every integer is a rational number will lead you to the fact that whatever numbers you have studied till now, they were all rational numbers. But does it mean that every rational number is an integer? Can you say that every rational number is an integer? So, I can say that minus 2 is a rational number and minus 2 is an integer, because minus 2 has been can be written in the form minus 2 by 1. So, it is a rational number, no doubt, and it is an integer as well. But does it lead us to conclude that every rational number is an integer? I can give you this example, 2 by 3. Is 2 by 3 an integer? Is 2 by 3 a natural number? Is it a whole number? No. 2 by 3 is not an integer, not a rational number, not a natural number and so on, but it is strictly a rational number. So, every rational number need not be an integer. We can conclude that every rational number need not be an integer. These are some of the facts. When you generate a new definition or generate a new idea, try to relate these ideas to whatever you have learnt earlier. What is the connection of that idea with the earlier learnt ideas? The numbers that we have studied, what is the connection of this number with the previous numbers that you have studied? And so, that will tell you how this knowledge with the situation, how it expands. You will yourself be able to generate this particular knowledge when you try to see the things in that particular concept from different views. Try to discuss among yourselves. Whatever exercises and the other things that are given in the textbooks, you should try to attempt and think over it. why this has happened, how this has happened, and where can it lead us to. And that will really create joy in thinking. Merely listening to someone will not give you the joy. Doing something with paper and pencil, discussing with your friends and concluding something out of it, some concrete thing out of it will give you joy, and try to apply that particular formulation to different situations that you face. So, this is what we intend to do, and this is how you can learn mathematics. You can learn how to learn mathematics, because many times we do not know how to learn mathematics. That is the problem. We simply feel that if I get a particular formula and if I am able to apply that formula, I know mathematics. If I am not able to apply that formula, I do not know mathematics. But let us see how these formulae or these algorithms are generated. Let us not merely restrict ourselves to that. Now, these numbers which I was talking about, that is 2, 0, minus 450, as I just now discussed, they are all rational numbers. Having discussed about rational numbers and introduced, though it has been introduced earlier also, now there is a broader classification of rational numbers as well. Just as you had negative integers and positive integers, there are negative rational numbers as well as positive rational numbers. For example, if I take the number like this, rational number like this, 2 by 3, where both of them are positive integers here, we will say that this is a positive rational number. This is a positive rational number, whereas if I say that minus 2 by 3, here you see that this numerator is a negative integer, whereas denominator is a positive integer. The ultimate number that you get is a negative number. So, we say that this is a negative rational number, or even if you say that 4 upon minus 5, here one of the integers is negative, the other integer is positive, again this is a negative rational number. So, you can generate such integers for yourself. The numbers, both the rational number are positive, will be positive in rational number, and if one of them is a negative integer, then the whole rational number will become a negative rational number. It will become a negative rational number. What about this kind of number? What can you say about this number? So, we have seen here both of them were positive, here one of them were negative, but here both of them are negative. So, what can you say about this particular rational number? I can write this, the equivalent form of this rational number will be minus 2 into minus 1 upon minus 3 into minus 1, the equivalent rational number. Just as you have studied equivalent fractions, similarly, you can multiply the numerator and denominator with the same number and try to get the next number, the other number. So, what is minus 2 into minus 1? I get 2, minus 3 into minus 1 is nothing but 3. What do you get here? You get a positive rational number. It means the number which I had written here minus 2 upon minus 3 can be written in the form 2 by 3, and so this is also a positive rational number. So, it means that, what is your conclusion? See, after observing the phenomena, after observing the numbers, if you try to generalize it, try to form your own opinions and principles, that is more important for us. Here I have shown you some numbers, some rational numbers in which either of them is negative, either the numerator is negative or the denominator is negative. We have said that they are negative rational numbers. We have seen the rational numbers in which either both of them are positive or both of them are negative. We have seen that they are positive rational numbers again. So, what is your conclusion then? So, either both the numerator and denominator should be positive, or both the numerator and denominator should be negative, then it becomes a positive rational number, otherwise it becomes a negative rational number. So, that is a broad classification for rational numbers, and just as we have in integers, the same kind of thing is proceeding further. This 0, as I said, is also a rational number, and so if I try to represent this on a number line, I can show you here that if I put 0 here, this is 1, this is 2, this is 3 and so on, this is minus 1, this is minus 2, minus 3 and so on. The number line which you have studied for integers. Now, how can I represent some rational numbers here? Let us try to do that. There are infinite rational numbers. I pick up 2 or 3 to show you how these can be represented here. For example, if I want to show 1 by 2, You know the rule of the number line, that whatever markings are there, they are all equidistant from each other. So, this is equal to this is equal to this is equal to this and so on. The markings are at equal distances. So, what I do is, if I want this 1 by 2, and as you have done in the case of fractions, I divide this particular section in 2 equal parts. I put a marking there, I divide this into 2 equal parts, and this is one part, this is another part, and I up from this particular point to this particular point, we will say that this is the half the distance covered, and so this point can be marked as 1 by 2. Similar kind of thing can be done on the negative side as well. This total distance is 1 unit, though the numbering is done as -1, -2 and so on, just to show you the difference between the two sides, but here the distance is 1 unit, and so exactly at half a distance, if I put a marking here, I can say that this is -1 by 2, half of the distance covered towards the negative side, half the distance, half unit covered towards the negative side, and I take this as -1 by 2. Similarly, here also I have covered 1 and again 1 by 2 I am covering. So, whole thing will become 3 by 2 or 1 and a half. This can also be written as 1 and a half. Similarly, if I go to the left here and put a marking between -1 and -2 at the midpoint of that, I will get this as -3 by 2, and so or you can say -1 and 1 by 2. These are all rational numbers. I have given you some simple rational numbers here where we can mark these numbers there. If you want 3 by 4, 7 by 4, 6 by 9, -6 by 7, all these rational numbers, the way you mark fractions, if it is a negative one, you will go to the left, you will mark it on the left side. If it is a positive one, you will mark it on the right hand side of 0. And in this way, you are able to represent the rational numbers on this number line. And so, whatever other concepts related to rational numbers that you have studied previously, I will be discussing them if I need it at that particular moment, but at the moment I will just discuss one important part, that is the standard form of a rational number. What is the standard form? Now, suppose I write the rational number in this form 2 upon -3, or I write a number of this form say 4 upon 8, and I write a number of this form say -5 by 7. So, these numbers you see, these are all rational numbers. Here there is a negative number, negative integer in the denominator. Here this particular number can further be simplified, can further be written in the simplified form as 1 by 2, and here you can see that it means that the common divisor of 4 and 8 is 4. Here the negative integer is there in the denominator, whereas here both these numbers are co-primes, that is I am talking about 5 and 7 simply. So, there is no common divisor here and the negative integer is in the numerator. Such a rational number in which there is negative integer is only in the numerator, not in the denominator, that is one condition. There should not be a negative integer in the denominator, and there should not be any common factor between numerator and denominator except one, that is both of them should be co-primes. Such rational number we say that is in the standard form. Such rational number is in the standard form. So, you can list some more standard forms like 2 by 3, -2 by 7, or say -7 by 9 and so on. They have no common factors here and the negative integers are in the numerator. So, that was all about the rational numbers up to standard forms. We will try to discuss some more problems based on this in our next session, where we will try to explore more ideas. Solving problems means exploring more and more ideas and getting our concepts more and more clear. So, that is all for the day, students. Thank you so much for being patient with me.